Okay, so this is the picture for this function, and then we need to evaluate each one of these questions. All right, Min, you're going to tell me what's the answer for the first one?
8.
Is 8?
Yeah.
Okay, so which one are you going to be using?
The first section.
The left one?
Yeah.
Okay, so it is equal to 8. And makes sense because a -4 is less than -2, so obviously we're going to be using this one. And here you can see that this makes sense because it's coming down, and the reason why it's coming down is because we have a negative gradient. Okay, so it makes sense. And the other one you can see is a positive gradient, so it will go up, and then we're adding 4. That's why the function actually starts from here. Okay, but then it goes up. Okay, so Ethan, what's the answer for B? 14.5. All right, 14.5. And finally, Archie, what's the answer for C?
I don't know. I didn't do it.
So you haven't done it
No, 'cause I
yet?
didn't get where you get the line from. 12.8.
Yeah.
What?
Sean got 17.8.
Oh, I got 12.8. No, I read the question.
Okay, if -7, obviously you're going to be using this one to calculate that one. And 1.2 is where? 1.2 is somewhere here, so you're going to be using the same one. Okay, so then you just simply substitute -7 here, and then 1.2 in here, and then you do what they say. And the answer is 12.8. Okay, so this is just basic substitution, nothing more than basic, very basic substitution. Okay, something that we did in year 7 and year 8. Okay, are you happy with this? Yeah. Okay, now we need to move on to the next set of exercises. All right. Can you please copy this number? Sean? Okay, I want you to copy this number, Ashton. Okay, so you're going to do exercise 4.02. I'm assuming that you've done exercise 4.01. That is the one that I gave you yesterday. Okay, so I'm going to show you later, Jasmine. Okay? Okay, 4.02. That is the next exercise, but now we need to move on. All right. Okay. We're going to go through some useful property of function. Obviously, there are many more, but we're going to start with the more elementary one, and then we're going to do the other one. Okay, so the first one is about the intercept. Okay, so intercept with the axis. So if you have the number plane, and you have, some function, And you know that sometimes function behave very, very weirdly. So sometimes you're going to have something that looks like, I don't know. All right. Okay, so sometimes you're going to have things that looks like that. Again, that is a function. Give it a go. And what we do all the time is to find the intercept of this function with the axis. So I mean, I really want to find that point, and that point whenever possible. Sometimes the nature of the function allows to find the y-intercept, but then sometimes finding, the x-intercept can be very, very complicated. In fact, sometimes we cannot do it. We use just approximation. Okay, I said it again. When you graph a function, it is highly desirable to find, the intercept with the axis. Finding the intercept with the y-axis is very, very much possible all the time. Okay, but finding the intercept with the x-axis sometimes is really, really hard. Okay. Right. Okay, and then we're going to continue. Here we go. So we're going to talk about the x-intercept. Okay. X-intercept. In general, if you want to find where the function crosses the x-intercept, then you simply make y equals 0. Okay, so you make y equals 0 if you want to find where the function is crossing the x-axis, the x-axis. We're going to say to find where the function crosses the x-axis. We solve for y equals 0. I'm going to change this. So we're going to say we solve. Yeah. So we solve whatever the function is equal to 0. Yes?
What kind of equation would we have to get like something as crazy as that? You know what I mean? Like.
Well, when you do later, we're going to be doing something that we call trigonometric function. Okay, when you do the trigonometric function, have you ever seen, well, there's nothing to do, well, it has something to do with it, but have you ever seen this curve?
Yeah.
Okay, and we call that the sine, a curve. Okay, so if you combine, well, this is the sine, cosine go like this. And then 10 is absolutely weird. So if you put these two things together, okay, and add, another sine function, multiply by 3 and add 1, then the combination of these two, so if you add them together, sometimes may picture like this. Okay?
I don't like. What does 10 look like again?
Hmm?
What does 10 look like again?
I'll show you one day, but not today. All right. Okay, so X-Intercept, you simply make y equals 0, which means you solve whatever the equation is equals 0. For example, example. All right, let's say that you have the function equal to, let's say, 2x plus 3. Okay, let's say that you have that. And they say that you need to find where the function cuts, the x-axis. Now, can you see that sometimes we're going to be using this notation? So we're going to say f of x equal to x plus 3. Sometimes we're going to say just y equal to x plus 3, because we know that y is equal to fx. So yeah, sometimes we're going to be using f of x, and sometimes we're going to just say y, right? Okay, so you have that, and then they say find where, the point where the function crosses the x-axis. Okay. Then you say solution. All you have to do is just to solve fx equal 0. So you're going to say fx equals 0. This symbol implies. I guess in mathematics, if you see that symbol, that simply means implies. So if you say f of x equals 0, that implies 2x plus 3 equals 0. Okay? Say 2x plus 3 equals 0. And then we find the answer for x. Okay? So x then is going to be equal to minus 3 on 2. That's it. Okay, so this is telling you that if you sketch this function will cross the x-axis exactly at that point. That's it. Too easy? Too easy. All right. Okay, y-intercept. Y-intercept, we do exactly the opposite. So we're going to make x equal 0. And that is always, well, most of the time is possible. Okay, so you can, yes.
On this solution, what's that little arrow thing made next to it?
Okay, this arrow means implies. Okay, so in mathematics, that means implies. So if you make that equal 0, that implies that this is equal to 0. Okay, that's all what we say. All right. Okay, so we're going to say to find where the function crosses the y-axis, comma, we make x equal 0 and solve for y. That's it. Example. So we're going to use the same example. So we're going to say find the point where the function fx equal to x plus 3 crosses the y-axis. Okay, y-axis. Solution. So we have f of x equal to x plus 3. And then they say all you have to do is just make x equal 0. So we're going to say f at 0 is equal to 2 times 0 plus 3. So therefore, f at 0 is equal to 3. Conclusion. Okay, first of all, this is what we call a linear function. Linear function because if you sketch, then you're going to have a line, all right? And in here, we already know that this function will cross the x-axis at -3 on 2. And in here, we know that this function will cross the y-axis at +3. So that is really good because now we can easily, because this is a line. So if we have these two pieces of information, then we can easily sketch this function. Okay, so let's say that this is 1, 2, 3. Okay, and this is, let's say that this is one somewhere here. Let's say that this is not to scale. This is -1.5. And if you know these two things, which are in this case very easy to work out, then you can easily sketch the function. Okay, so you know that it's going to go through these 2 points. That's it. And then normally we put the name of the function in one of the end. All right? Yes?
Isn't it the case that at the start, when you just have fx equals 2x plus 3, you already know the y-intercept because it's plus?
Yeah. When you have a linear function like this, you know that the constant is telling you where the function cuts at the y-axis. Yeah, that is correct. Okay, the constant always show you that. Okay, but this is what we done. Okay, so we already know what piecewise functions are. You already know how to draw them. You already know how to evaluate them. And also we know what we mean by X-intercept, and we know how to find it, and we know how to find the Y-intercept. Okay, and we can see that that is very useful when sketching, particularly when sketching, straight lines. All right? Okay.